Welcome to Module 1 Uncalled Exceptions Demo 4. In this demonstration we're going to show the concept of a scope guard. We have been working on demonstrating updating two vectors where they both get updated or none get updated in a null or none transaction commit scenario. This is an extension of that concept. So what we're going to do is the same as before. We have our two vectors and our string that we're going to use as an element. We push the string onto the first vector, and then we create this vec_scope_guard object here, which wraps around the vector. If we come up here, we can see the class for vec_scope_guard. We have the constructor and the deconstructor and a disengage function. We have two private members here. We've got engage and vec pointer. So engage gets set to true on construction, and the vec pointer gets assigned to the parameter. If engaged is still true when the destructor is called, we pop back the last entry on the vector, so we remove the last entry. And we have the disengage function, which basically sets engage to false. So the way we use this is we create the vec_scope_guard object around the vector, and then we carry on doing whatever it is we want to do, updating the second vector. Then we create another vec_scope_guard object around the second vector, and we could do this for any number of vectors. And then if all goes well, we call the disengage function on both these guard objects. Then we print out the size of the vectors so we can see that they've both been updated with the same amount of elements, so they're both been synchronized. Then we clear the vectors to proceed to the next demonstration. So we have the same code again. We push the string onto the first vector, create the scope guard around the first vector. However, then we're going to create a bad alloc exception and throw it. This is to replicate what would happen if the update to the second vector failed, maybe due to insufficient memory being available. So none of this code here gets executed, because once we throw the exception, we jump to the exception handler. So what happens is when we jump to the exception handler, the vec_scope_guard object we created here, gab1, moves out of scope. Therefore, the deconstructor is automatically called. And when the deconstructor is called, we remove the last entry on the vector because we haven't yet called disengage, which would happen at the end to set the engaged member to false. That removes the string we added onto the vector here. In the exception handler, we print out a couple of statements we call exception, and we print out the vector sizes so we can see that the vector sizes are still the same. In other words, the element we push on here has been removed when we guard1 moved out of scope to the exception handler. So let's just run that and have a look. Okay, so we can see here, first use of guards, vector scope OK, with the sizes both being 1. Then we get caught exception because we've thrown the bad alloc exception. And we get second use of guards, vector size 0 and the second vector size 0. That's even though we've actually pushed an element onto the first vector. So here the vectors are actually 1, 0, and then we throw the exception, which is called here, which invokes the deconstructor in gab1, which removes the element we added here. So therefore both vectors are still got 0 elements.